Here we are. We're learning how to use factoring to solve equations. So that's a nice feeling that what we've been doing for the past, I don't know, it feels like 5, 6, 7 sections. What we've been doing actually is useful in real life, solving equations. And then in the next section after this, we'll actually see where are equations like this actually used in real life. But first, let's just talk about how do you solve equations by factoring? How is that going to help us? So first thing we learned in this section is here the definition of what a quadratic equation is. So a quadratic equation, it's an equation of the form ax squared plus bx plus c equals 0. So you notice there it's a trinomial on the left side. It's one term with an exponent of 2, ax squared, and a is just some constant, whatever the coefficient of x is. And then you have a bx, which is the term with the x to the 1 power, and a constant term. So it's a trinomial, which we kind of learned how to factor trinomials. They broke it up into 2 sections because it depends if the coefficient of x squared is 1, or in other words, if a is 1, then you can factor it fairly easily. But if a is not 1, then you have to use that complicated method where you have to draw that x thing and figure out what's a times c and what numbers add up to this and multiply to that. Anyway, so we know how to factor those, but we have to figure out if it's now an equation. So now I've added an equals 0. Now that there's an equal sign, I'm actually, instead of me being able to just rewrite it in a different way, or factor it or simplify it, now that there's an equal sign, I actually have hope of solving an equation. I can figure out what x is. And the way we're going to do that is here with the second line here, the principle of zero products. So that says that if you have an equation of the form a times b equals 0, so an a times b, just think of those as, they could be anything. It doesn't have to be just one number times one number. It could even be something like factors, x minus 1, x plus 3. So think of x minus 1 as a, x plus 3 is b. So if you happen to have an equation like that where two things are being multiplied and it's equal to 0, then that would mean that you can conclude one of them is equal to 0. Either the first part of the product, a, is equal to 0, or the second part of the product is equal to 0, or both. And actually, you know what? That makes sense if you think about it, because you don't know what a and b are. Let's just think of them as numbers. With our experience in the past multiplying numbers, just think about, okay, a and b, I don't really know what they are, but I do know that when I multiply them together, I get 0. So in your past experience, if you multiply two numbers and get 0, that's got to mean that one of them is 0, right? At least one of them. Maybe it's 0 times 0, or 0 times 5, or 10 times 0. It could be any kind of combination, but I think one of them has to be 0. If you multiply two numbers that are not 0, you're not going to get 0, right? It has to be that one of them is 0. So that's really all they're saying in this principle of zero products, that if you multiply two things together and you get 0, that means one of them has to be 0, or maybe both are 0. You never know. All right. So we might as well use that to start solving equations here. And I'm not sure why I put example 2 here. It should be example 1. There's only one example in the section with a bunch of problems in it. But let's see if we can use that. So look at part A. It says x plus 3 in parentheses, x minus 4 in parentheses. Those multiplied together equals 0. So I could say by that principle of zero products, that means either the first part of the product, x equals 0, x plus 3 equals 0, or the second part of the product, x minus 4 equals 0. One of those has to be true. So basically when you have two things being multiplied together and they equal 0, you can set each of them equal to 0 separately and then solve them from there. So to solve the left portion, x plus 3 equals 0, I'm going to subtract 3 from both sides. If I do that, I end up with x equals negative 3. So there's one solution, but I'll have another solution by solving this other equation that I found, x minus 4 equals 0. If I add 4 to both sides, it looks like I'm going to get x equals 4. So there are two solutions. You have to contain, or your solution is going to contain two parts to it. It's going to be x equals negative 3 and x equals 4. So both are solutions. And if you really wanted to, you could check your answer. Like what if you wanted to check, okay, the original problem looked like x plus 3, x minus 4 equals 0. let's say I check x equals -3, the left solution that I found. I'll check it by replacing the x's with -3 and seeing if I actually get a true statement. Let's see here, if I put -3 for both x's. So notice that what's in the left parentheses, -3 plus 3, that's going to be 0, times the right parentheses, -3 minus 4 is -7. And that is equal to 0. So the left side is equal to the right side of the equation. That means that that must be actually a solution. And something similar would happen to our other solution here. If you put 4 in there, so imagine instead of putting an x equals -3, I put x equals 4, then it would be 4 plus 3, parentheses, times 4 minus 4, parentheses, equals 0. And you notice it just makes the right portion equal to 0 instead of the left portion. So it'll be 7 times 0 equals 0. But that's true. 0 does equal 0. Alright, that means both of these are solutions. You don't really have to check. Usually, as long as you're careful in your work, you're going to get the right solutions. But if you just want to be safe, then it's a good idea to check. But it really is true. We found the only two numbers that would make it so that if I substitute that value in to the equation, I'm actually going to get a true statement. That's pretty amazing. I think so. This might be the first time we've seen one equation where we get more than one solution. So we'll see that more and more as we go along. There'll be some equations with 2 solutions. We'll even see some with 3 maybe. And then next semester you might see even more. Okay, let's try this next one here. So part B, notice this guy, it kind of has almost 3 things being multiplied together on the left side. It's 2 times, parentheses, 3t minus 5, parentheses, x plus 4. Whoops, that should be a t, sorry. T. It should all be the same variable. They'd never give you a different variable in more than one. Yeah, they wouldn't give you 2 different variables in one equation for these. Okay, so since there are 3 things being multiplied there, 2 times 3t minus 5 times, that means that we're going to set each of those equal to 0. Basically, the principle of zero product says no matter how many things are being multiplied, you're going to set each of those things equal to 0 and solve for your variable. In this case, the variable's t. Alright, but if you look at the left one that I set up there, 2 is being multiplied, so he gets to be set equal to 0. But when will this ever happen? This will never happen. When is 2 equal to 0? So this will give you, you won't be able to produce a solution from this left portion. We will get a solution from this middle one and the right one. So really, when you have a constant term multiplying in the front, that's not going to give you any solution. You'll only get a solution out of a factor that has a variable. That might even be worth pointing out. Only factors containing variables contribute to the solution. Yeah, but any constant multiple or factor that's like we have in the front, the 2, it's not going to contribute to the solution. It's just kind of there, and it's not going to affect our solutions at all. So that one, I set it equal to 0 because that's what the principle of zero product said, but it's not really necessary. Now I'll just try to solve the middle one here. Let me add the 5 over to the other side. That way the 3t's by itself, 3t is equal to 5 now. And now if I divide both sides by 3, then I'll have t by itself, and I'll know one of the solutions, t must be 5/3. That's not the prettiest solution I've ever seen, but I guess that's one of them. Alright, let's try this last one here. T plus 4 equals 0. I'll solve it by subtracting 4. So it looks like t equals -4 is the other solution. There we are. So we have 2 solutions, not 3. Even though we set 3 things equal to 0, like we pointed out, you're not going to get a solution out of constant factors. If it's just a number in the front, that's not going to really give you a solution. We did find 2 of them, and if you were to substitute either of these values in for the t's, you would get a true statement. So we know that we've done this right. Alright, let's try the next one here. Part C, you notice now, you can think of -7z as its own kind of part of this product, and then 5 minus 2z, they're being multiplied together. I'm going to kind of do the same thing. I'm going to set -7z, the first part of the product, equal to 0, and then the 5 minus 2z equal to 0. You're kind of thinking of the -7z as your A in the zero product property up here, and then the 5 minus 2z as your B in the zero product property. And even though it kind of looks like the left portion it's a constant sort of, -7, but because there is a variable there, z, it is actually going to give us a solution. But if it was just -7 instead of -7z, then we would not get a solution here. But to solve for z, I'm going to divide both sides by -7, and I think that'll do it. Let's see now, then z would be equal to, if you remember, 0 divided by anything is 0. It's when it's upside down. If it was -7 divided by 0, that's when it would be undefined. So z equals 0 is one solution. We got one. Now let's look solving the other one here. If I want to solve for z here with the 5 minus 2z equals 0, I'm going to have to move the 5 over first by subtracting it. That'll give me -2z equals -5. Then I'll be done when I divide both sides by -2, the coefficient of z. And since it's a negative divided by a negative, it'll be z equals +5/2. So there are two solutions. Z equals 0 and z equals 5/2. Perfect. All right, we did it. So I think we're getting the hang of this, right? This is pretty good. Not bad, not bad. All right, let's try this next one. Although you notice that they're almost like they're taking the training wheels off here, sort of. Because in part D here, they did not factor it for us. In all the other parts, someone's already factored what was on the left side of the equation. So now it's our job to first factor it. Because you can't use the zero product property until the left side of the equation looks like two things being multiplied. But notice that the left side of our equation, that's not two things being multiplied, that's three things being added or subtracted. It's x squared, subtract 6x, plus 5. So you're going to have to make this look like the product of a few things. You know, two things being multiplied maybe. But factoring will get that done. So we have to now factor first. Factor, then set each factor equal to 0. That's kind of our extra step here. Alright, so I have to think back. Let's see, which factoring technique should we use here? Well, the left side is a trinomial. It has three terms. And so this could either be the easy factoring method, where you just kind of write down the answer like this, like you say, oh, it's x and x, what multiplies to this and adds to this, and we're done. Or it could be the harder one. It depends if the coefficient of x squared is 1 or not. Luckily, in ours, the coefficient of x squared is 1. So all we have to do is figure out what kind of numbers multiply to 5 here, and then add up to -6. I think that's going to be -5 and -1. Or vice versa, it could have been -1, -5. But those two have a product of +5 and a sum of -6. So those are the right guys. And now that we factored it, it does look like the product of two things. It's x minus 5 times x minus 1. So now we can use the property of zero products, where we set each factor equal to 0. The first factor equals 0, the second factor equals 0, and then we'll solve each one separately. Solving the left one would involve just adding 5 to the right side. And then solving the right one would involve adding 1 to the right side. So here on the left one, we'll end up with x equals 5. On the right, we'll end up with x equals 1. And there are our solutions, 5 and 1. And if you were to check either of those, if you substitute either of those into the original, let's just choose 5, I guess, for fun. Let's see. If you check 1, it would also work, but I'm going to replace both x's in the original equation with a 5 and see how that goes. So 5 squared minus 6 times 5 plus 5 equals 0. Let's see how this goes here. Let's see, 5 squared is 25, minus 6 times 5 is 30, and then plus 5 equals 0. I think that's true, because 25 minus 30, that's -5. -5 plus 5 is 0. So 0 equals 0. Okay, the left side and the right side were the same. You know, they end up being the same number, so that must have been the correct solution. And if you were to check the other one, if you put a 1 in there similarly, you would get a true statement as well. 0 equals 0. So we know we've done it right. Okay, sounds good. Now let's try part E here. This is another one where the left side of this equation does not look like the product of two things. It looks like the sum of two things. Two things are being added. I'm going to have to factor it first. And looking at the left side, I see that there are two terms. And remember, if you want to factor something, the first thing you think of is there a common factor I can factor out? And this one does happen to have these two terms have a y in common. And if I factor a y out, 2y plus 7 would be left. And that must equal 0. And that's really all the factoring I can do. The thing in the middle, 2y plus 7, that can't be factored further. There are no like terms between 2y and 7. It's not like the difference of squares or the difference of cubes. There's nothing really I can do now, so I'm just going to take each factor, the y in the front, set it equal to 0, and the 2y plus 7 inside, and set that equal to 0. And you know what, we got kind of lucky. On the left one, we don't really have to do anything to solve. It's already kind of solved for us. Y is already isolated. The y equals 0 must be one solution. And I'll find the other one by solving for y in this other equation, moving the 7 over by subtracting it. 2y equals negative 7. And then I'll divide both sides by 2 to get this other solution here. Okay, it must be y equals negative 7 halves. Alright, there are two solutions. Y equals 0 and y equals 7 halves. Or sorry, negative 7 halves. So either of those would work. Alright, I think we're doing good. We're more than halfway through this section. These kind of all go the same. It's more like, I don't know, just remembering how to factor, and depending on what you're given, what factoring method do I use, you know? That's kind of the tricky one. Alright, so let's try this next one, part F. So you notice, let me just, to remind ourselves, let's go back to that the principle of zero products. Remember what it says is, before I wrote all over it, what does it say here? It says, an equation of the form a times b equals 0 is true if and only if a equals 0 or b equals 0 or both. But notice the equation you're starting with is something times something equals 0. So you can only use this zero product property if you have something times something equals 0. But in part F, if you notice, we start with something that you don't have a 0 on the right side. So really, this one, there's kind of an extra step as well. You have to move all terms to the left side. Because if I move all terms to the left side, then the equation will look like something, I don't know, I'll put it in quotations, something equals 0. And that's the only way to use the zero product property. That's why they call it the zero product property, because 0 is an essential part of it. You have to have 0 on one side of the equation. And this is the first one where we haven't seen that, so I'm going to have to move this 4y over maybe to the left side. By subtracting it, of course, since it's positive. That would give me, and I want to make sure I write these in descending order of powers. So the y to the third power has the highest power, and then the 4y has the next highest power. Alright, now this looks sort of similar to part E, the previous problem, because there's two terms now, and if I want to factor this, they have something in common. They both have a y in common. So I think I'll first take a y out, and then what would be left? Y times what is y cubed? That would be y squared. Y times what is negative 4y? Well, that would be negative 4. Alright, we factored the y out, but I think, unlike the last problem, part E, this part, what's left in the parentheses, can be factored further, because this is the difference of squares. So remember, it's something squared, or something to the second power, minus something to the second power, since 4 is 2 squared. So I'm going to leave the y outside the same, but the y squared minus 4 you can write as y minus 2y plus 2. And now I think I've factored this as far as I can. I can't really simplify that anymore. So the last step is to take each of these factors. There are 3 of them this time. This is the first time we've seen 3. We're going to set each one equal to 0. The y outside equals 0, the y minus 2 inside equals 0, and the y plus 2 inside equals 0. We'll actually have 3 solutions to this one. The very left one, there's not much you have to do there. It's just already solved for you. So I'll just kind of box it. Y equals 0, there's one solution. If I add 2 to both sides, in the middle here, y equals 2 is your next solution. And then the last one, if I subtract 2 from both sides, looks like y equals negative 2 is your solution. So there are all your solutions. There are 3 of them. Y equals 0, and y equals 2, and the last guy, y equals negative 2. That's a lot of solutions, right? 3 of them. And if you take any of those 3, one at a time, maybe take y equals negative 2, for example. If you take it and replace it in the original equation here, it's going to give you the same number equals the same number. All 3 of these are correct solutions. We found all 3 of them. There are no solutions that we didn't list there. There are no solutions besides 0, 2, and negative 2. We found all 3 of them. That's pretty amazing, right? I think so. Alright, that one was fun. Let's see about part D here. So part D, this one I think is actually a little nicer than the last one. Let's see, okay, this one looks like x squared minus 36 equals 0. We have all terms on one side already. It's 0 on one side, so I don't have to really worry about moving anything. All terms are on the left side. That's something I can say. Okay, check. No need to move everything like I did in the last one. Now I'm just going to focus on, okay, how do I factor this guy? Well, this is the difference of squares, kind of similar to what we just saw. Because it's, okay, what can you square to get x squared? It'd be x. And then remember, difference of squares always factors with a plus and a minus, or a minus and a plus. And then what can you square and get 36? That would be 6. Alright, that's as far as it can factor. Either of those things in the parentheses, x minus 6, x plus 6, there's nothing you can do to factor those further, so that's it. Now that it looks like the product of two things, I'm going to set each one equal to 0, and then solve either one for x separately. So on the left one, I'm going to add 6 to both sides to move it over, and I'll end up with x equals 6. There's my first solution. The second one I can get by taking the one on the right and subtracting 6. That way x will be equal to negative 6. Alright, there are my two solutions, x equals 6 and x equals negative 6. And if you test either of those in the original equation, you plug it in, you will get a zero. I mean on both sides. You can kind of do it in your head, you know, this was our original equation. What if you put a 6 right there for x? 6 squared is 36. 36 minus 36, that is 0, right? And the same thing for the other guy. What if you put a negative 6 there? Negative 6 squared, that's negative 6 times negative 6, which is positive 36. Positive 36 minus 36 is 0. So those both do work, okay. So a lot of these you can kind of check in your head. Some of them are kind of too complicated, and if you want to check them, you might actually want to write it out, where you're really substituting the values in. But alright, that sounds good. Let's try part E. So part E, notice you do not have all your terms on one side. I see z squared and 1 are on the correct side, but 2z, I don't know what happened to that guy. He kind of wandered off, got lost, so we got to bring him back. 2z, what are you doing? Get over here with your friends. I'm going to subtract you. That sounds like a threat, huh? I'm going to subtract you, z. Man, that's kind of scary. Alright, anyway. And then now that I have 3 terms on the left, because there were already 2 there, and there's 1 that I've moved, I want to write them in descending order of powers. So I got z squared is going to be the highest power, but then minus 2z is the next one. 1, the constant term, is the last one you want to write. And now I'm going to try to factor this, now that I have all the terms on one side. So in this one, since it's a trinomial, and there's no number in front of z squared, I should be able to just kind of do this the easy way, where it's just going to be a z and a z, and then I ask myself, okay, what multiplies to 1 but adds up to negative 2? I think that would be a negative 1 and a negative 1, right? Negative 1 times negative 1 is 1. Negative 1 plus negative 1 is negative 2. So this is kind of weirding me out that those are the same factor, but let's pretend like we don't know anything weird is going on, and we'll set each factor equal to 0 now that it looks like a product. Z minus 1 equals 0 and z minus 1 equals 0. I'm pretty sure we're going to get the same solution here, right? We're going to add 1 to both sides for this guy. I mean, I might as well do it for both of them, huh? So z equals 1 is one solution, and z equals 1 is the other solution. So really there's only one solution here. I just got it twice. So you'll see that happening. Sometimes there's only one solution to these. It doesn't happen very often. But if there's only one solution to these guys, that'll mean that you're probably going to get that solution twice. That still only means there's one solution. It just happened to occur twice. And you'll see in if you happen to have to take pre-calculus or let's see, what is it? College algebra. You'll see what that means as far as the graphs of these things. So it's kind of interesting that it affects the graph. I'll tell you, I don't give a crap. No, just kidding. The fact that that solution occurred twice means that the graph of this guy hits that x-intercept once. So these guys, their graph looks like a parabola, this kind of U-shape. So anyway, it kind of just touches the x-axis and comes back up. It only hits the x-axis one time, and that's why there's only one solution. That's as opposed to, like in part D there. Part D, it was x squared minus 36 equals 0, and we got 2 solutions. So since there are 2 solutions, that corresponds to 2 x-intercepts. There's one of the solutions, negative 6, and the other at the other solution. But it's still a parabola, this shape here. So that's what these really mean if you're, if you're going on in math. These will represent the x-intercepts of the graph of these guys. So a lot of times there are two x-intercepts like you see in part D, but once in a while there's only one, like in part E. Anyway, sorry if you don't care about that, but that's just why that happens. Alright, let's look at part F. So this is the last one, and this is probably, if you see one of this type, it's kind of the most not painful, but it's tedious and it takes a while. But if you can handle this one, you can handle anything. So look at in part F, at first I was thinking, oh look, the left side's already factored for me. Aren't they being nice? Look at that, it's so pretty. But remember that the left side being factored is only helpful if the right side is 0. Like in the first couple examples we did, where are those guys? Let's see. Yeah, notice in part A, it was some product, or the product of two things or something factored equals 0. But the equals 0 was the only reason we were able to set each factor equal to 0. Same thing for part B here, and part C. But since we don't have a 0 on the right side, you know what, it seems like I said, it seems like they were being nice by factoring it. We actually have to multiply this out. FOIL and bring the 7 to the left side. It's like someone someone factored it for us. They factored it way too fast. They kind of jumped the gun. They didn't have all their terms ready, but they factored it anyway. And then we'd say, all right, you did a lot of work to factor that, but that was kind of useless because you needed to have all the terms, even the 7, involved in that factoring. You just wasted a bunch of time. Now I have to undo that and bring the 7 over and combine it and then factor it again. So, all right, let's FOIL this thing out, and then we'll see what to do from there. Damage control. So, okay, first times first, x times 3x would be 3x squared. And then outer, x times 5 would be 5x. Inner, 3 times 3x would be 9x. Last would be 3 times 5, that's 15. And then equals 7. Alright, so I see there are a couple like terms on the left side there. You got 5x and 9x. Those can combine to make 14x. And then you have the plus 15 equals 7. And like we said, I would like the left side to be factored, but it's only useful if there's nothing on the right side. You have to bring everything over and involve everything in the factoring. Not just the nice numbers. So let me move the 7 over by subtracting it. Then I'll have 3x squared plus 14x plus 8 equals 0. And now I have to refactor. Ugh. I don't know why it reminds me of, like, I don't know if you ever bought like furniture or something from IKEA, or furniture from somewhere, and you try to assemble it yourself, or someone tries to assemble it themselves, and they put it together, but then they look down at the leftover parts, and there's a bunch of leftover parts. Or there's at least one leftover part that looks really important. You say, uh-oh, maybe I better disassemble this because I think I missed something important, even though it took me a long time. Anyway, that's kind of how I think about the original problem. Someone factored it, but then they look on the right side, they say, uh-oh, I was supposed to factor it with the 7, uh-oh. Well, let me undo everything, pack everything up, and involve everything, and then redo it. Alright, now we have to factor this guy. So you notice what we have here, 3x squared plus 14x plus 8. That's a trinomial, but there's a coefficient of x squared that's not 1. So we're going to have to use those tricky methods like the grouping method or the FOIL method. But I think I'm going to use that grouping method. I like that better. So if you remember, you make a little x and you say, alright, first what's a times c? So it's the first term times the last term, or the coefficient. 3 times 8, that would be 24. So I need to know what multiplies to that but adds up to the middle guy, 14. Alright, let me think about that. What multiplies to 24 but adds up to 14? Let me see. Well, 24 could be what? 1 times 24, but there's no way you're going to add those and get 14, right? What about 2 times 12? Oh, that's the winner. 2 and 12, right? 2 times 12 is 24. 2 plus 12 is 14. Alright. I think we've got it. So then the next step, even when you find those numbers, it's hard to remember what to do with them. But then the next step is you rewrite the first term exactly the same, 3x squared. The last term exactly the same, plus 8. It's the middle term you're going to split. So it was a 14x, but he's going to split into two terms, something x and something x, where their coefficients come from these numbers here, the 2 and the 12. put a plus 2x for the first one, and then plus 12x for the second one. There we go. So that's always how it goes. The middle term splits into two terms, where the coefficients are the numbers that you just obtained. Alright, now we're going to factor by grouping, and we're almost home free here. This is where I'm going to split it down the middle and then say, alright, between the first and the second term, what's their common factor? Between 3x squared and 2x, I think all they have in common is an x, that's it. And if I factor an x out, 3x plus 2 is left. Alright, now if I focus on the third and the fourth term, between 12x and 8, they have a 4 in common. And I'll put a plus 4 because there was a plus above it. Alright, let's see, if I take the 4 out, 4 times what is 12x? That would be 3x. 4 times what is 8? That would be 2. Alright, and we must have done everything right so far, because the things in parentheses are the same. 3x plus 2, 3x plus 2. If I factor it out, okay, of each of the big terms, if I take 3x plus 2 out of this guy, what's left? X. Plus, what if I take 3x plus 2 out of this guy? 4 is left. Okay, now that we've factored it all we can, now we're going to set each factor equal to 0 finally, and we'll be able to solve this guy. This is definitely the most tedious and the most difficult type of problem in this whole section. So this guy's equal to 0, this guy's equal to 0. I'll solve the left one by first subtracting 2 from both sides. Then I'll be left with 3x equals negative 2. Dividing by 3 will leave me with my first solution, x equals negative 2/3. There he is. Alright, and I'll get another one from this other guy, x plus 4 equals 0. That one's not too hard to solve, I'll just subtract 4. It must be x equals negative 4 is the other solution. There we go. Man, that was tricky. But just keep in mind, I think that one's kind of just a lesson to show you, it's not enough to factor, you want to make sure you factor when you have all the terms on one side. So if you're missing someone, if that's not 0 on the right side, it's something else, you miss something and you need to move it over, undo the factoring if it's already factored, kind of combine like terms, and then refactor with everything combined into one trinomial or whatever it is. And then once you factor, then you can set each one equal to 0. Those are very tricky. Be really careful on those ones. So those definitely take practice, and I think if you're good at factoring at this point, or sort of fairly proficient, these will be a lot easier. But if you're still struggling with factoring, that's going to be difficult on these. So it's really good to practice factoring before you try to tackle this section. Alright, but thank you for listening. I will see you in the next video. Bye.